Hi everyone, welcome to the class. Please confirm once that am I audible to you or not. Hi Shilong. Okay, can you please share the topic that we were discussing in the previous class? Hi Itanago. Topic, please. And do you have any doubt or query for me? Whatever topic or concept which is not clear to you, you can please ask me. Packing efficiency. Okay, what's the doubt in that? Okay, sorry, that was the last topic that we have discussed. Okay. I guess we have discussed the density as well, and we have done the numericals based on that. Okay. So let's start with the next very important and interesting topic, which is closed packed structures. Closed packed structures. Okay. So first is closed packing in 1D. One D means one dimension. I hope so you have seen the axis x, y and z axis. Okay. So if we use only one of the axis, I'll simply say it is a 1D dimension, 1D, which is one dimensional. If I use the two axis, I'll say it is a two dimensional. If I use three of the axis to represent something, means I can see the three views over there, means three we can say faces or whatever geometry is there, three sides at the same time. I'll say it is what? The 3D geometry. Okay. If I can see only one, it is what? 1D. If I can use the two, then it is what? 2D. So in 1D, if I ask you that atoms are arranged like this. Okay. Okay. Now my question is, I have marked this sphere. How many other spheres, or we can say how many atoms are touching the marked sphere or marked atom? How many spheres you can see? Yes, you're supposed to give the answer, no? How many spheres you can see that touching the given sphere which I have marked? Itanagar, Shillong. Okay. Shillong, what's your answer? Yes, absolutely. You can say one is this one, another one is this one. So So actually there are two atoms which are touching the given atom. So you can check out in the whole layer, or we can say in the whole line, if I left the first and the last, okay, please do not include the first and the last line, or we can say the last atom. Other than this, if you pick or check out any atom, you will find that every atom is being touched by other two atoms. Okay, so this is the coordination number, which is 2. So coordination number is nothing but it is the number of atoms that can be touched, or we can say that are touching by the other atoms in a present, or we can say the given geometry. Okay, so this is your coordination number. Ultimately you have to check that how many other spheres can touch a given sphere. Okay, so in the close packing in 1D I can have the coordination number 2. Okay, now close packing in 2D. Okay, look at this arrangement. This is close packing in 2D. Okay, now this is case 1. Check out this sphere and tell me how many other spheres are touching it. Count the number of spheres which are touching the given sphere. Very good. Yes, answer is 4. See? Okay, as you can see, it looks like a square. Okay, just because all the layers are exactly same here, that's why this is known as what? AA type of arrangement, and this is known as what? Square close packing. Okay. Okay, and yes, coordination number will be the 4. Now next arrangement. Now look at this, or let's say suppose this is A type of layer, this is B type of layer. Just because they are not starting at the same point, or we can say they are a little bit different from each other. Okay, so this is again same A type of layer, this is same the B type of layer. Now check out this sphere, the yellow sphere. Tell me how many other spheres are touching it. Good, Itanago. Very good. Yes, answer is 6. And I hope so. You can see it looks like hexagon. See, it looks like hexagon, and which is formed by AB type of arrangement. This is known as hexagonal close packing. Coordination number 6. Okay, please copy. Hi, good evening, Satna. Welcome. Copied. Okay, copy and then confirm. Satna, have you copied that? Okay. Now, close packing in 3D. First of all, let's talk about the simple cubic. Okay. Now guys, you have to imagine something. Okay, let's begin. Can anyone please answer one thing? How many spheres are touching the purple sphere? How many other spheres can touch this purple sphere? In one unit cell only, means in the given one. How many spheres are touching the purple sphere? Shillong Itanagar. We know na atoms of the corners touches each other in the simple cubic that we have already discussed. See, one second. Obviously, this is one. I'm just marking it. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So, atom 2 obviously is touching atom number 1 because they are the neighbors. Whatever neighbors are there will touch each other. So, 2 will touch A, 4 will touch A, and 7 will also touch A. Okay. So, I'm marking this in this manner. These are the atoms which are touching number A. Are you clear with this one? Is there anyone who is having any doubt? Guys, please do not copy anything. Say I'm discussing a concept. If you skip that, if you will be busy only with the writing, you won't get it. Okay. So what I'm saying that atom number 1, which is a purple sphere, will be touched by number 2, number 4, and number 7. Is there any doubt in this one? Are you clear with this one? Itanagar, Shillong. Okay. I'm saying there is one more unit cell. See. Look at this, which is actually present here. Let's make it a little bit far. I'm saying this is another unit cell. This is exactly the same type of unit cell which is present. Okay. Actually, we are talking about 3D now. So obviously we won't have the one unit cell. We will have many unit cell, and I'm just trying to count that in the whole crystal lattice, in case of the simple cubic, what is the exact position, or we can say what is the exact probability that how many atoms can touch a single sphere, and that will be true in throughout the crystal. Okay. Now look at this. One second. They all are red. Okay. They all are red. See. Just remove them. Okay, guys, one thing. If I simply touch these two spheres, so can I say this is nothing but the purple sphere? Can I say this is nothing but the purple sphere? Just look at this. These two walls are common actually. Let's suppose this is wall number 1 and this is wall number 2. These two are common to each other. Now, if these two are common to each other, then obviously what can I say? I am talking about the single atom. Is it true? Try to think about it. Okay, try to imagine a room. Okay, try to imagine a room in which you are sitting right now. Exactly the same room, means walls is common. Walls is common. Is on your left hand side or right hand side. So can I say that one corner will be common there? If wall is common, then obviously the corner should also be what? Common there. I'm saying that the wall number 1 and wall number 2 are exactly common to each other. When I'll place near to this one, so this should also be the wall number 1, and both the spheres are exactly same. And in this case, what can I say? That this atom will also touch the purple sphere. Can I say that? Shillong, Itanagar, Satna. Guys, are you getting this? If you are having doubt, please ask me. Itanagar, are you there? Okay. So actually what I was trying to say, see, I can draw one atom here from the unit cell which is present on the left hand side, that is also touching it. Obviously there will be one more atom which will come from top side, that will also touch it, and yes, one more atom which will come from the front side, that will also touch it. Now tell me, how many atoms are touching the purple sphere? This is the exact possibility. How many atoms are touching the purple sphere? Itanagar, Shillong. Okay, good. So this is the coordination number in the simple cubic. Coordination number is 6. You can pick any sphere. If you pick any sphere, always will get the coordination number 6 in case of the simple cubic geometry. Got it? Please copy. Now you can draw it. Guys, I'm repeating, if you are still not getting it, please just let me know. Please copy and then confirm. Okay. Let's move on. Number 2, body centered cubic. I am putting a sphere inside the unit cell. See, if atom is present at the center of the body, it touches every corner. Now tell me, how many other atoms can touch this atom, this green sphere? See, if you want to learn the concept, at any point, if you think it is not clear to you, please ask me. Second thing, if you just want to solve the question, just remember the results. This the special thing about this chapter is, if you simply even remember the even remember the results, you will always get the answer. Oh, that is a fumble. You can smile on that. Yeah. Okay. Cool. Yeah, sometimes it happens to me. Slip of tongue. Okay, yeah, Shillong has given the answer. Satna has given the answer. What about the Itanagar? How many spheres can touch it? Obviously, this one will touch it. This one will also touch it. This one will touch it. This, and this. All the atoms will touch it. So, coordination number is 8. So, in case of the BCC, coordination number will be the 8. Okay. I hope so you are getting the coordination number. Done? Okay, next FCC. We know that in case of FCC, at every faces you will find the atom. So obviously, I'll get the atom on this face, this one, and this one. Now, let's begin. In the given unit cell, tell me, in the given cube, how many spheres can touch this purple sphere? How many other spheres can touch it? Good. No Itanagar, think about it again. No. See. All corners will touch it. Imagine your wall, an atom on that wall, and the 4 corners which are touching that sphere. Obviously, 4 corners, 4 atoms, 4 from the corners. Obviously, the sphere which is inside the cube will also touch the atom which are present on the faces of the other walls, except the diagonally opposite part. Obviously, so I can say this one will touch it, this one will touch it, because these are the exact neighbors. This one and this one. How many? Right now, how many? Good. 8. I am saying one more thing to you. Just look at this. This is one more sphere which is present over there. Okay, now put the atoms. Still purple sphere. Okay, and these are your atoms which is on the faces. Now tell me, how many other spheres? This is the situation. Now tell me, how many total spheres can touch the purple sphere? Yes, absolutely correct, Satna. What about you, Shillong and Itanagar? See, obviously this face, this face, this face and this face. No common wall, and in the two cubes one wall is common. Now the question is, on that common wall how many other walls are common to it? You will say total 8 walls. 4 from the left side, 4 from the right side. Okay, so 4 atoms which are present at the corners will be common. They will be counted only once. But the atoms which are on the faces of on the left hand side of the wall or on the right hand side of the wall are not common actually. So they both will be counted. So 4 from the left side, 4 from the right side. Total atoms that we count for the coordination number will be 12. You can remember, FCC has got the 12 coordination number. Clear? Please copy it. Copy and then confirm, and yes, mark that how you are getting the 12. Copied? Okay, let's move on. So that's, you have to remember that simple cubic has coordination number 6, BCC has 8, FCC has 12. Now, generation of voids. Okay. Placing second layer over first. First of all, just look at your screen, do not copy it. Okay. am drawing HCP type of arrangement. Okay, this is AV type of arrangement. What I am doing, I'll place the same type of layer above this. Okay, so look at this. One second. No. One second, I'm drawing it. Guys, one second. Look at this. This is the situation actually. See, there are two type of possibility. If I draw that over there, I'll show you that how those that arrangement will look like. Okay, but before that, see how the voids will be generated if I place that layer. Okay, that will take too much of time, so let's do this. See, this is one type of layer. I have picked a section from that layer of the three spheres. Now let's suppose this is the bottom layer. This is the bottom layer. Now on this layer I'll put another layer in such a manner that the sphere will be placed like this. So you can see that this part, this triangular part is totally covered. Okay, three spheres, you are having the three spheres, you are just putting another sphere just to cover that hollow part. Okay, the triangular part that I have made over there, I was just trying to cover that. To cover that, I'll simply put another sphere over it. Okay, so if such type of arrangement is possible, means when we arrange the layers, so actually this is one of the possibilities. Okay, and yes, this arrangement, or we can say right now this space is known as what? Tetrahedral void. Okay, now along with this one, there is also one more possibility over there. Look at this. This same kind of that triangular space over there, but yes, the difference is this time triangle is pointing downwards. Okay. Now look at this. See, this is another type of possibility, and here the space, or we can say the void which is generated, is known as what? Octahedral void. Just because its geometry or dimension, we can say, looks like octahedron, that's why we say it is the octahedral voids. So actually when we place two types of layer on each other, so it generates the two types of layer, two types of voids. One is the tetrahedral void and another one is your octahedral void. Okay, so this is ultimately the voids that will be generated on placing the layers on one another. Okay, so in spite of drawing this, you can simply copy this one. Please copy it. I hope so you are clear with this one. If you are having doubt, you can please ask me. Please confirm once after copying that. Okay, so let's move on. One more thing, because we will have the questions based on this one, that let n be the number of close packed structures, or we can say the spheres, not structures, close packed spheres. Then the number of octahedral voids generated are n, and the number of tetrahedral voids generated 2n. Okay, that's what you have to remember. I'll tell you that how to use it, but right now please copy it. Done? Okay, placing third layer over the second. See actually what sequence is going on. Look at this. This is your first layer. Okay, this is your first layer. Now when you place another layer over this one, it will generate the voids, okay, which is tetrahedral voids and the octahedral voids. Okay, now when you will place the third layer over the second layer, it will actually the attempt to cover the layers, sorry, to cover the voids. Okay, so whenever we are placing the third layer over the second layer, it means that we are covering the voids. Okay, so this is the next part, and yes, the first part is covering tetrahedral voids. Now look at this. Let's suppose this is A type of layer. Okay, now this is B type of layer. Just imagine, see this part and this sphere. Whenever you will put these 7 spheres which are looking like hexagon on the B type of layer, so it will generate tetrahedral void. Now look at this. I am drawing again B type of layer. See, this is also what? Tetrahedral voids. Now we have generated the tetrahedral voids. Now again A type of layer. See, if we make such type of arrangement, AB type of arrangement in the 3D, okay, so what will happen, that if I place the 2 layers, look at this, if I talk about the bottom 2, it will generate the tetrahedral void. If I put another layer of A onto it, so what will happen, that tetrahedral void which is being generated over there will be totally covered. Okay, so after covering this, if you check out, this one will actually will look like this. See, these dots are the spheres. Now these 3 spheres. Now again these 7 spheres. Okay, now once you join them, see this part with this one, this part with this one, this part with this one. Okay, is it look like a hexagon? Is it look like a hexagon? This was A layer, B layer, A layer. Okay, so if you cover the tetrahedral void, finally it will generate the hexagonal close packing. Okay, now you can copy it. Please copy it. See, I am covering only one tetrahedral void. Don't be confused that why I am not considering the above three spheres. You can consider, okay, you can consider, then you can have another hexagon over it. Okay. I'm not getting your question, Shilong. Can you please make it more clear? Okay, you are asking that how this hexagon will be formed. See, simply, or when you look at the AA type of layers, okay, when you simply look at the AA type of layers, one layer is simply introduced between them. That is responsible for the, yeah, I can explain it. That is responsible for what? Tetrahedral void generation. Okay, so simply what happens if you check out those faces, I can say that if you simply visualize that, this is nothing but the visualization. Okay, if you visualize that, it will looks like a hexagon. If you would like to cover the only tetrahedral void, and if you visualize it clearly, it looks like a hexagon. Okay, once if, first of all you have to copy it, and then I'll draw something else into it to make it much more clearer. Or simply I can say it is nothing but the visualization. Okay. Please copy and then confirm. Look at this. Sphere, sphere, sphere. They all are what? Spheres. Okay. Look at this. They all are what? Spheres. Okay, so what I was doing, I was simply doing this one. See, if you meet, let's suppose this is atom number 1, this is atom number 2. Okay, this is exactly here. So this is what? Atom number 1 and atom number what? 2. Okay, so if you exactly place these two layers above each other, what will what will happen? See, I am simply removing these atoms which are present inside, just to visualize it much more clearer. See, now is it look like a hexagon? Now are you clear with this one? This was nothing but the visualization. Clear? Over now. Next, covering octahedral void. Okay, look at this. Guys, be careful into it. See, first of all, you have to answer one thing, that can they form the octahedral voids? Can they form the octahedral voids when I place these two on one another? This is A type of layer, this must be the B type of layer. Can they form octahedral void if I place them over one another? Yes, they can. Okay. And yes, just to make it much more clearer, guys, just look at your screen. Okay. No, why? Check out the octahedral voids where I have discussed the octahedral voids. These two are exactly same. Okay, now look at this. I'm just drawing their neighboring atoms just to just to make more clear that how it will turn into the FCC. Okay, see, this is the neighbor atom, this is the neighbor atom, this is also the neighbor atom. Similarly, neighbor atom, neighboring atom, and also neighboring atom. Still they are forming the octahedral void. Okay, now please keep in mind, just because of this they are forming the octahedral voids. I hope so up to this one everything is clear. Okay, now if I would like to cover this red region, I have to put a sphere obviously, and that sphere should be of the different layer. So I am drawing that sphere which is here. Obviously this sphere, let me draw it with the red. This red sphere will cover the red octahedral void. So I am saying it is a C type of layer. Similarly, I can put a sphere here which is also covering it. This is what? Again C type of layer. So you will see that in covering the octahedral voids, the arrangement is actually the ABC type of arrangement. Okay, so let's suppose this is atom number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I have 14 spheres. I am using 14 spheres. First of all, you have to just tell me, are you clear up to this one? Are you clear how octahedral voids are generated and how I am covering it? Shillong, is it clear to everyone? Okay. Guys, now do not copy anything. Okay, not clear. Okay, what's your doubt? St. Paul. See, I have just, see, this will generate the octahedral void now. If I place the layers like this. Just separate these layers. So we will see one of them will be of B type and another one will be of the A type. See, this is AB type of layer. And after that I have just drawn their neighboring atom. Okay, just to clear that how it will turn into the FCC. That's it. Now clear? Guys, just look at your screen. Be careful. See. This is your atom number. One, two, three, four, five, six, 7, 8, 9, 10, 11, 12, 13, and then 14. Okay. 14 points for the 14 spheres. Now please look at your screen and observe it. Look at this. The red dots are representing the atoms. Check out their positions and tell me, is it look like FCC? Is it look like FCC? The angle of view is totally changed. In the FCC, you were initially observing that the cube was present along the faces. Now I have just changed that, and now I am saying it is present along one of the edges. I have simply turned it, and after turning it, look at this. Corner atoms, see, corner atoms, they all are what? Corner atoms. I have simply tilted that. Okay, as you can see, there are total 6 faces. See, these are the face atoms. So this is your cubic close packing, CCP, or also known as the FCC. Please copy it. So whenever you will cover the octahedral void, it will generate the CCP type of arrangement. Clear? Copy and then confirm. Okay. Can anyone please tell me on the basis of this one, if I talk about this sphere, consider these 4 layers. How many other atoms are touching it? How many other atoms are touching it? How many total number of atoms are touching it? No. Shillong? Wow. Obviously, these 6 are touching it. Even these 3 are also touching it, na? You are covering the void. If you are covering the void, so obviously this is the covering atom. So this one will touch the atoms which is below to it and as well as which are present in the above layer. Now count how many total atoms are there which are touching it. Wow. 6 from this one, 3 from here, 6 from here and 3 from here. It should be 12. So this is the coordination number. For the hexagon HCP, coordination number is 12. Please copy it. And yes, remember this one as well, packing efficiency is 74% for this one as well. Please copy this data as well. Packing efficiency is 74 and coordination number is 12. Okay. Now let's look at a question. A compound is formed by two elements. Please copy this question along with me. X and Y, atoms of the element Y as anions make CCP and those of element X as cations occupy all octahedral voids. What is the formula of compound? Please copy and then after that just look at your screen. Okay guys, look at this. Compound is formed by two elements X and Y. Atoms of Y make CCP. Okay. CCP means, see, you can solve this question in two ways. First, we know that in the CCP effective number of atoms are what? 4. Okay. Then X are occupying the octahedral voids. We know that octahedral voids are equals to what? Whatever total number of spheres are there. Effective number of atoms are there. So obviously X should also have what? 4. So it is nothing but 1:1 format. So I'll have the molecular formula as a XY. Or if you don't want to do this, you can do this one as well. We don't know how many CCPs it will form. So just consider it as a N, about which we were talking in that note section. That if N be the close packed structures, which is the number of spheres, then obviously octahedral voids form what? N. So it is N:N. So on solving, again you will get what? XY. So it's your choice whether you would like to start with the number of atoms exactly which is present in the particular type of the structure, or you can simply start with the N or X. Okay, you will get answer in both the ways, and after that you have to solve this question. This question is for you. Atoms of element B form HCP lattice and those of element A occupy 2/3 of tetrahedral voids. What is the formula of compound formed by A and B. Please solve this and tell me the answer. Confirm once after copying that. Okay, let's solve this question. A and B form HCP, so let's consider it as N, or you can simply say it is 6. Tetrahedral voids, so voids will generated be 2n, but it is saying it occupies only 2/3 part, so simply 2/3 part, n and n will get cancelled out, so this is 4:3. Formula is what? A4B3. Copy. How many of you has got the correct answer? Raise your hand. Shillong Center. And rest can use the chat screen. Only one. Okay. One more question for you. Everyone has to solve it. I'm not writing the whole language. It's P, N, CCP and Q. 1/4 of octahedral voids and R 2/3 of tetrahedral void. Solve this one. What should be the formula for this one? If anyone is having any confusion, you can please ask me. Done? Okay, so let's solve this. CCB means you can consider it as a n. So first of all, Q is saying octahedral voids, so it should be n. Tetrahedral voids means it should be 2n. Now it is saying it occupies the 1/4 part, so I'll simply put 1/4. It occupies 2/3 part, so I'll put the 2/3 part. N will simply get cancelled out from every place. So I'll have the new ratio that will look like this: 1:1/4 4/3. As we know, we can't leave these ratios like this, so I have to simply convert it into simple whole ratios. So obviously I need a number that can help me in this one. So I'll multiply all the numbers with 12. Okay. So after multiplying it with the 12, this is 12 is to 3 is to 16. Okay. So the formula will be what? P12 Q3 R16. Shillong, how many of you has got the correct answer? Well done, Satna. What's going on, guys? Is there any confusion in this one? Itanagar, St. Paul. All has got the wrong answer. Shillong. Next question. P atoms are present at the corners Q at body center. Okay. Determine coordination number of P and Q. Okay. We are discussing the coordination number. Yes, that's already been covered. Corners has 6, body center has 8. That's already covered. Okay. That's already done, na? Simple cubic and the BCC. HCP B. All tetrahedral voids C 3/4 octahedral volts. Formula of the compound. Guys, I'll share the notes of the polymers metallurgy with you on the group. Please take the printout of that. Okay. So in the next class we will wind up with this chapter. We are only left with the point defects. Okay. And after that we will study those chapters. See, we are left with the theoretical chapter only, polymers, and then your metallurgy. Okay. So I'll share the notes with you and I'll discuss those notes with you. We won't write anything. You have to simply study from that notes. Okay. Means I'll discuss those notes in detail with you, and once we will have discussion on that, you will simply get that. Okay. And yes, as these are the theoretical chapters, if you want you can also study on your own as well. Okay. Means self study. So let's see, I'll share those notes with you. Please keep the printout of that. Now let's solve this question. ABC. This is n, this is 2n, this is 3/4n. On solving, you will have 4, 8, 3. A4, B8, C3. This is the answer. Yeah, biomolecules as well. Okay. Done? Okay, so that's all about for today's session. Thank you so much. See you next time. Till then, take care. Bye bye. Good night.